Today we are graphing cube root functions. The parent graph of a cube root function is f of x equals the cube root of x. You can take an odd root of a negative number. So our domain is all real numbers, and it is increasing as x approaches infinity. Our x-intercepts, it goes through the point 0, 0, so x-intercept is 0, y-intercept is 0, and it is positive for x values greater than 0 and negative for x values less than 0, and it is symmetric about the origin. And our general form for a cube root function is g of x equals a times cube root of x minus h plus k. When we graph the g of x equals 1/3 cube root of x, a is 1/3, h is 0, k is 0. So it's centered at the origin and vertically compressed by a factor of 1/3. Our domain is all real numbers and the range is also all real numbers. So if I were to substitute -2 in for x, we would get out -0.42. You can type these into your calculator to find your y values, and then we will plot the points on our graph. So -2, -4.2, -1, -0.33, 0, 0, 1, 1/3, 2.42. And then when you connect your dots, it kind of makes this like S shape here. Make sure you include arrows on both ends to indicate that the graph continues on, and our domain and range are all real numbers. The next one, we're going to graph p of x equals cube root of x plus 5. So there's an understood 1 in front of our cube root, so a is 1. H is -5 because we are minusing -5. K is 0, so we're not adding anything outside of the radical. So the function is translated 5 units left from the parent graph. Our domain is all real numbers, and the range is also all real numbers. So if I were to type this into my calculator, y equals cube root of x plus 5, and go to the table, I can fill in the table and then plot those points. So starting with -7, -1.26. I guess my points pop up out of order here. Okay, and then connecting those, we get that same shape as our parent graph again, but going through those points. When you have rounding, you're just going to like estimate the best you can and try to draw your curve going through all your points. For part C, we have got the cube root of 4 minus x plus 1, and that function, we could rearrange it a little bit. So we have the x first, and we factored out -1 from the expression under the radical. This way we can see that it is reflected and translated 4 units right and up 1 unit. And then substituting in these numbers for x, we would generate this table with our calculator and then plotting our points, 2, 2.6, and then 3, 2, 4, 1, 5, 0, and -6, -1, -0.26. Okay, so here's what our graph looks like. It's a little bit different shape because of that reflection, and then it has been translated right 4 up 1. In example 6, we are comparing two radical functions. So this one here is a square root function that starts at 1, 2, 3, 4, 5, 6, 0, and then we have all negative y values. Over here we've got a graph that is a cube root function, and the table is shown here. For p of x, the domain was all real numbers and our range is also all real numbers, but for q of x, it was x is greater than or equal to 6, and your range was less than or equal to 0. You can go ahead and pause this to read the comparisons and looking at your guided notes to see where all of that came from, and then you can resume that when you're ready for the next example. Example 7. Write a radical function for the graph of g of x. So when we look at that, we can see based on the shape that that is a cube root function. It's not a square root function because a square root just gives you one arc with a restricted domain. You can see we're going to the left forever, an arrow to the right. So if the domain's all real numbers, that means the index is 3, as in we have a cube root function. You can also see instead of going through 0, 0, we have this point here that it's symmetrical about. And then that helps us, that point right there is -3, 1, 2, 3, -4. So then that tells us h and k. And to solve for a, we are going to pick a point that's on the graph. So I'm going to use this point -2, -2, and so we can solve for a. So I'm going to substitute -2 for x and -2 for g of x, and then we are going to substitute -3 for h and -4 for k. Looks like this. All right, so when we take under the radical sign first, -2 minus -3 is 1. The cube root of 1 is 1, so we have a times 1, which would just be a. To solve that for a, we would add 4 to both sides. So now that we know a, h, and k, we can now write our function. G of x equals 2 times the cube root of x plus 3 minus 4. Thank you for watching.